Several potential issues could cause a ground fault circuit interrupter, or GFCI, breaker not to trip when used with Plugmold. Firstly, the ideal GFCI plugin tester might not be compatible with the SQD or SQD GFCI circuit breakers. Different brands of GFCI devices sometimes have different tripping mechanisms or sensitivity levels. Secondly, ensure that the Plugmold is properly wired, with the line and load terminals connected correctly. Improper wiring can prevent the GFCI from tripping. Thirdly, the test current generated by the plug-in tester might not be high enough to trip the GFCI. A more sensitive GFCI tester, one with a higher test current, may be required. Fourthly, consider that the SQD GFCI circuit breaker could be defective or faulty. Replacing the circuit breaker and retesting might be necessary. SQD GFCI circuit breakers are designed to be used with standard electrical outlets and devices. Plugmold is a specialized type of electrical distribution system designed for specific applications. While it is generally possible to use SQD GFCI circuit breakers with Plugmold, there might be compatibility issues with certain models or configurations. Several recommended steps can help resolve this issue. 1. Contact the manufacturer of the SQD GFCI circuit breaker to verify which GFCI testers are compatible with their breakers. 2. Inspect the wiring of the Plugmold and ensure that it is correct according to the manufacturer's instructions and local electrical codes such as the National Electrical Code, or NEC 2008. 3. Use a different GFCI tester with a higher test current to see if it trips the breaker. If the above steps do not resolve the issue, replace the SQD GFCI circuit breaker with a different brand or model that is known to work with Plugmold. Always ensure that all electrical work is performed by a qualified electrician and complies with all applicable electrical codes and regulations. The NEC section 210.8 discusses GFCI protection requirements. The NEC Article 380 covers multi-outlet assemblies, which would include Plugmold. Be sure to consult these sections for specific requirements related to GFCI protection and the installation of multi-outlet assemblies. For example, NEC 210.8. It requires GFCI protection for receptacles installed in bathrooms. If the Plugmold is installed in such a location, it must comply with this requirement. Also, NEC 210.12 requires arc fault circuit interrupter, or FSI protection for branch circuits that supply dwelling unit outlets. While this is different from GFCI protection, it is another important safety requirement to consider. When dealing with electrical circuits, it is important to verify the voltage and current ratings of the devices involved. For a standard 120-volt circuit, a 20-amp breaker is commonly used. Ensure that the Plugmold and all connected devices are rated to handle the voltage and current supplied by the circuit. Use a multimeter to check the voltage at the Plugmold outlets to confirm that it is within the acceptable range, typically between 110 volts and 125 volts. When testing the GFCI breaker, the tester simulates a ground fault condition. This condition occurs when current flows through an unintended path, such as through a person to ground. GFCI breakers are designed to detect this imbalance in current and trip the circuit quickly, preventing an electrical shock. The typical trip current for a GFCI breaker is around 5 mA. This means that when the difference between the current flowing into the circuit and the current flowing back is 5 mA or more, the breaker should trip. The plug-in tester you are using is designed to simulate this condition by creating a small ground fault. If the breaker does not trip, it could indicate that the breaker is not functioning properly, the tester is not providing enough current, or there is a wiring issue. When inspecting the wiring, pay close attention to the neutral and ground connections. Ensure that the neutral wire is properly connected to the neutral busbar in the panel and that the ground wire is connected to the ground busbar. Also, make sure that there are no loose connections or damaged wires. Loose connections can cause voltage drops and overheating, while damaged wires can create a risk of electrical shock. When replacing the GFCI breaker, be sure to choose a breaker that is compatible with the panel. Circuit breakers are typically designed to fit specific types of panels, so it is important to select the correct one. Also, make sure that the breaker has the same voltage and current rating as the one being replaced. For example, if the existing breaker is a 20 amp, 120 volt GFCI breaker, the replacement should have the same rating. After replacing the breaker, test it again with the plug-in tester to ensure that it is functioning properly. If the new breaker still does not trip, there may be a more complex wiring issue that requires further investigation. When working with Plugmold, it is important to follow the manufacturer's instructions for installation and use. Plugmold is designed to provide multiple outlets in a convenient location, but it must be installed properly to ensure safety. Make sure that the plug mold is securely mounted and that all connections are tight. Also, avoid overloading the plug mold with too many devices, as this can cause overheating and potentially lead to a fire. The ampacity of conductors is a critical factor in electrical installations. The NEC Table 310.15 B16 provides ampacity ratings for insulated conductors based on their size and temperature rating. For example, a 12 American wire gauge, or AUG, copper conductor with a 75 degrees Celsius insulation rating typically has an ampacity of 25 amps. However, the overcurrent protection device, such as a circuit breaker, must be sized according to the conductor's ampacity. In this case, a 20 amp breaker would be appropriate for a 12 AWG conductor. When installing wiring in conduit, the NEC specifies the maximum number of conductors allowed in a conduit based on the conduit size and the conductor size. This is to prevent overheating and ensure that the conductors can be properly cooled. The NEC Chapter 9 provides tables that list the allowable conduit fill for different types of conduits and conductors. When making wire connections, it is important to use the proper connectors and techniques. Wire connectors, such as wire nuts or terminal blocks, should be sized appropriately for the conductors being connected. The connection should be tight and secure to prevent loose connections and overheating. It is also important to follow the manufacturer's instructions for installing wire connectors. Grounding is an essential safety measure in electrical systems. Grounding provides a low impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and to energize the circuits. The NEC requires that all metal enclosures and equipment be properly grounded to prevent electrical shock. Grounding electrodes, such as ground rods or metal water pipes, are used to connect the electrical system to the earth. Surge protection is another important consideration in electrical systems. Surges, or transient overvoltages, can damage sensitive electronic equipment. Surge protective devices, or SPDs, are designed to protect equipment from surges by diverting the excess voltage to ground. SPD are typically installed at the service entrance and at individual branch circuits to provide comprehensive surge protection. Electrical panels should be properly labeled to identify the circuits and their corresponding loads. This makes it easier to troubleshoot problems and perform maintenance. The NEC requires that all circuits be clearly labeled with their purpose. The labeling should be durable and easy to read. Regular electrical inspections are essential for maintaining a safe and reliable electrical system. Inspections can identify potential problems before they become serious hazards. It is recommended to have electrical systems inspected by a qualified electrician on a regular basis, such as every 3 to 5 years. When working with electricity, it is important to follow all safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician. The NEC Article 110 covers general requirements for electrical installations. This article includes requirements for working space around electrical equipment, access to electrical panels, and the proper use of electrical equipment. Be sure to consult this article for general safety requirements. The NEC Article 250 covers grounding and bonding requirements. This article includes requirements for grounding electrodes, equipment grounding conductors, and bonding of metal enclosures. Be sure to consult this article for specific grounding and bonding requirements. The NEC Article 300 covers wiring methods. This article includes requirements for the installation of conductors, cables, and raceways. Be sure to consult this article for specific wiring method requirements. The NEC Article 400 covers flexible cords and cables. This article includes requirements for the use of flexible cords and cables, including their ampacity and allowable uses. Be sure to consult this article for specific requirements related to flexible cords and cables. When dealing with electrical equipment, it is important to use equipment that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, ORL. This ensures that the equipment has been tested and meets safety standards. Look for the UL mark on electrical equipment to verify that it has been listed. When selecting electrical equipment, it is important to choose equipment that is appropriate for the application. Consider the voltage, current, and environmental conditions when selecting equipment. Also, make sure that the equipment is compatible with the existing electrical system. When installing electrical equipment, it is important to follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on how to install the equipment properly and safely. Failure to follow the manufacturer's instructions can void the warranty and create a safety hazard. When performing electrical work, it is important to use the proper tools. Use tools that are designed for electrical work and that are in good condition. Avoid using damaged or worn-out tools, as they can be dangerous. When making wire connections, use a Torx screwdriver to ensure that the connections are tight and secure. Torx screwdrivers are designed to apply a specific amount of torque to the screw, which helps to prevent loose connections. When working with conduit, use a conduit bender to bend the conduit to the desired shape. Conduit benders are designed to bend conduit without damaging it. When pulling wires through conduit, use a wire pulling lubricant to reduce friction. Wire pulling lubricant makes it easier to pull the wires and prevents damage to the insulation. When terminating wires at terminal blocks, use a wire stripper to strip the insulation from the wires. Wire strippers are designed to strip the insulation without damaging the conductor. When testing electrical circuits, use a multimeter to measure voltage, current, and resistance. Multimeters are essential tools for troubleshooting electrical problems. When using a multimeter, be sure to follow the manufacturer's instructions and take all safety precautions. Electrical safety is a serious matter. Always be aware of the potential hazards and take steps to protect yourself and others. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Remember to always prioritize safety when working with electrical systems and consult the latest edition of the NEC for detailed requirements and guidelines. When replacing a GFCI breaker, ensure the new breaker has the same voltage and amperage rating as the old one. For example, if the old breaker is a 120 volt 20 amp GFCI breaker, the new one should also be a 120 volt 20 amp GFCI breaker. Using a breaker with a different rating can create a safety hazard. After installing the new GFCI breaker, test it immediately using a GFCI tester. If the tester does not trip the breaker, double-check all wiring connections to ensure they are correct and secure. A loose or incorrect connection can prevent the GFCI from functioning properly. If the wiring is correct and the tester still does not trip the breaker, the new breaker may be defective and need to be replaced. When working with Plugmold, be aware of the maximum load that the Plugmold can handle. The maximum load is typically indicated in the Plugmold itself. Do not exceed the maximum load, as this can cause the Plugmold to overheat and create a fire hazard. If you need to connect multiple devices to the Plugmold, consider using a power strip with surge protection. A power strip can provide additional outlets and protect your devices from power surges. However, be sure to choose a power strip that is UL listed and has a sufficient ampacity rating for the devices you will be connecting. When installing Plugmold, follow the manufacturer's instructions carefully. The instructions will provide detailed information on how to install the Plugmold safely and correctly. Make sure that the Plugmold is securely mounted to the wall or other surface and that all connections are tight. If you are not comfortable installing Plugmold yourself, it is best to hire a qualified electrician to do the job. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Before starting any electrical work, always turn off the power to the circuit at the breaker panel. Use a voltage tester to confirm that the power is off before touching any wires or component. Wear insulated gloves and safety glasses to protect yourself from electrical shock and arc flash. If you are working in a damp or wet environment, be extra careful to avoid electrical shock. Never touch electrical equipment with wet hands. If you are not sure how to do something safely, ask a qualified electrician for help. It is always better to be safe than sorry when it comes to electricity. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The NEC is available for purchase from the National Fire Protection Association, or NFPA. You can also find information about the NEC on the NFPA website. Electrical safety is a shared responsibility. By following the safety tips and guidelines outlined in this discussion, you can help to prevent electrical accidents and ensure a safe electrical environment for yourself and others. If the issue persists after trying these steps, consult a qualified electrician to diagnose and resolve the problem. They can perform more detailed testing and inspections to identify the root cause of the issue and ensure that the electrical system is safe and compliant with all applicable codes and regulations. Remember that working with electricity can be dangerous, and it is always best to err on the side of caution. If you are not comfortable performing any of these tasks yourself, hire a qualified electrician to do the work for you. Their expertise and experience can help to ensure that the electrical system is safe and reliable. Consider documenting each step taken during troubleshooting, including test results, wiring inspections, and component replacements. This documentation can be helpful for future reference and for communicating the issue and resolution to others, such as the inspector or other electricians. The documentation should include the date and time of each step, as well as any relevant observations or findings.